Consider a graph where the x-axis represents the distance in dots on an image, while the y-axis specifies hypothesis quality. Now, within the document image, multiple text fields resembling one another are positioned within the rectangles R1, R2, and R3. Our goal is to capture the specific text located in the R2 rectangle. We can say that this rectangle is located nearest to the right boundary of the page. However, the R3 rectangle is also located nearest to the page right edge. Then we can argue that the R2 rectangle is located nearest to the upper boundary of the page. But here we have the R1 rectangle located nearest to the page top edge as well. The Advanced Designer Extraction Rules activity allows us to use only one nearest condition for a certain element. In other words, we cannot say both nearest to the page top edge and nearest to the page right edge. In such cases, fuzzy logic proves useful. The idea is to measure the distance between the targeted search element and the position of a known page element, such as a page boundary or a previously found rectangle. As this distance approaches 0, the quality of detection becomes closer to 1, as depicted in the graph. The larger the distance, the lower the quality, represented by the corresponding fuzzy intervals. On our example page, if the distance between the R2 rectangle top and the document page top boundary equals 0, the quality then equals 1. The bigger the distance, the smaller the hypothesis quality. Look at these graphs. The corresponding fuzzy intervals are here. You can see that on these intervals, the first three values are the same and equal to 0, while the last value indicates the angle of the line. You can see that the bigger this last value is, the greater the angle, and the more gradually our graphs reach the null hypothesis quality. In other words, the closer the distance between the R2 rectangle top boundary is to the page top edge, the higher the hypothesis quality will have. Utilizing FlexiLayout Language's fuzzy quality function permits us to specify a fuzzy interval, and then it adjusts the element's hypothesis quality accordingly. For instance, if we're specifying the proximity of the R2 rectangle top to the page top edge, we can utilize the fuzzy quality function fuzzyQuality r2.rect.top minus pagerect.top 0001,000 times dots. Here, this red text represents the calculation of the distance between the top of the R2 rectangle and the top of the document page. The green text sets the fuzzy logic parameters by which the quality of the element's hypothesis can be calculated. What we are saying here is that the quality changes according to this line we see on the graph, with the base distance in dots of 1,000. We need no calculations to see with our own eyes that the distance between the top of rectangle R3 and the page top edge is bigger than the position of R2, which means that the quality of the R3 rectangle hypothesis is smaller. But the fuzzy quality function arrives at this same conclusion algorithmically. The Advanced Designer Extraction Rules activity allows having as many fuzzy quality functions simultaneously as might be needed. This is why, in those cases when we want to specify that an element is located proximate to several objects, like in our case, closest to both the right and the top, we can have two fuzzy quality functions. Note that this is impossible with the nearest to function. Let's add the second required fuzzy quality statement. Fuzzy quality page.rect.write minus rect.write 0001,000 times dots. Note that I intentionally deducted the smaller value from the bigger. Look, the top boundary of the R2 rectangle is located below the top of the page, which means that its y-coordinate is bigger. Similarly, the x-coordinate of the right boundary of the page is definitely bigger than the x-coordinate of the right boundary of the R2 rectangle. Sometimes we don't know which boundaries of given elements will be bigger. This is why we can use fuzzy intervals with negative values as well. sometimes we might have a negative result of subtraction. If you don't want to consider which value is higher, then if the resulting value is negative, we need to adjust our fuzzy intervals so they reflect both negative and positive results, like this. Fuzzy quality rec.top minus pagerec.top minus 1000, 00, 1000 times dots.